Hello everyone, just wanted to give a quick update. It's been a while, so no ride today. Just want to say I did actually went ahead and bought the parts for the gas generator. I want to do a detailed hybrid plan review. Also, it looks like I need to switch my 72 volt system back to 36 volt temporarily for the generator setup because it just well I'll get to it later when we talk about the actual converter, but it looks like that it's not able to convert the voltage from the generator to the bike at 83 volts, but we can talk about it later. So basically no ride today, just a quick talk about, not a really quick talk about it, but just a talk about the plans for the generator. um, Let me preface this by saying that I'm not a great mechanic or a machinist or electrician. So I might stumble a little bit along the way, and I might do some things that are wrong and not quite the way that they're supposed to be done, and everything might just blow up. So yeah, so hopefully we'll learn together, and we'll get this going. Um, Yeah, so the first thing I'm going to talk about is the plan. And sorry, this is the first time I'm doing a voiceover recording of still shots, so it might be kind of jotty here and then, or I might have some awkward pauses. But here's the plan coming up. So the plan is to first I'm gonna get as I mentioned before, I ordered all the parts already. So when the 25cc two-stroke motor gets here, I'm going to start it up, check the different choke settings, check the idle, and also check the different rev ranges. The second thing I'm going to do is I'm going to assemble the actual generator setup as much as I can without connecting it to the bike or anything like that. After that, I'm going to test the converter for the voltage ranges. So basically turn on the engine into the generator, into the converter, and check the converter for the voltage range, the current, and also the memory to make sure it memorizes the correct current. Um, After that, I'm going to assemble the mounting plate on the actual bike to match the generator plate, and you'll see that in the next in the generator design. After that, I'm going to test the generator and the e-bike only, so no battery. This is important because you want to make sure that the voltage is consistent and it's not doing anything crazy to harm your battery or blow up your battery. So just going to do a voltage check over that. After that, I'm gonna hook it up to the actual battery and the whole system as it will run, and I'm just gonna test it with a battery load. So basically, just ride around my cul-de-sac, which is about a mile here. Test it under just a heavy load. So basically, it shouldn't be charging the battery, or just idling, which I'm sitting at a stop sign or to stop somewhere, so it should be fully charging the battery. Um, the last thing I'm gonna do is I'm gonna try to route the generator throttle line back to the unused gear changer. So I used the gear changer for the rear sprocket, but not for the front pedal chainring. So there's three different levels there. I'm hoping I can use that to set the throttle line or set the rev set the rev for the gas generator so that I can control the amount of power from the handlebar and not have to stop the bike and change the idle, to adjust the power. And sometime along this, as I mentioned before, I need to convert this 72 volt system back to 36 volts, which would suck because then it wouldn't be a 3000 watt system anymore, max continuous system anymore. It will be closer to 1500 max continuous and possibly 1200, which is still okay. That should go around 32 miles per hour max speed, but there's no way I'm gonna go 50 miles per hour, which I was hoping to do at some point on this bike, if I'm brave enough. But this is just a quick, I think you've seen this before. It's a schematic of how the setup will look in the actual bike. Note that third battery is not going to be there. That B3 is not going to be there. Of course, it's going to be 36 volt for testing, not 72 volts. But overall, it's going to look similar to that. The generator is going to sit on the back rear rack. The gas generator or the gas engine will be first, and then that will be coupled to a 500 watt DC motor, and that will route back into a parallel setup with the battery. the generator, and then the motor. So here's the schematic of the actual design of the generator. And the only difference here is that it's not going to be 83 volts coming out of the setup controller. It's going to be 42 volts, or 42 or 41 volts, or 41.5 volts. So we'll have the gas engine, which is a 25cc gas engine, and that will be mounted onto a board, onto a mounting board, and we'll do a shaft and coupling design, and that would connect to a 500-watt electric generator motor, and that would supply DC current to a watt meter, which on the back I have 2 watt meters, so I'm gonna put a watt meter back there just to see what it is for testing. So I'm hoping I get around 20 volts and around 300 watts, 200 to 300 watts, with a medium to high idle coming out of this engine into a 500-watt generator. Then that's going to go into a step-up controller, and a step-up controller basically takes a lower voltage and moves it to a higher voltage. In this case, it will be 41.5 volts. And you'll lose some power through that way. It says between 95%, 90 to 97% efficiency. So in this case, if we're taking in 300 watts, from the generator, we're gonna probably lose around 10%. No, so to 270. And finally, that will go back to a parallel connector with the battery and going to the motor. And the stock gas tank at the top will be removed from the actual gas engine. Usually it's at the bottom of the gas engine, so I'll remove that and I'll put that to the side of the board. And this is a top view of the schematic. It's not going to be mounted like this. This is the top view. So the gas engine will sit upright, obviously. And the board and the mounting plate here will be flat against the actual bike, as you've seen in the previous picture. So a couple of things that could probably go wrong. So when I looked at the that YouTube video I mentioned previously that had the the tutorial how to do this, they used a 33cc gas two-stroke gas engine, and I assumed wrongly that the 25cc will have the same mounting holes at the bottom, but there's actually no mounting holes at the bottom. I think there are a couple places where I can use the screw holes, which are into hard plastic, as locators, but I will have to find a better way to mount the gas engine to resist the vibrations from the motor. Also, and here is the gas engine I bought. Is a used, tested, cleaned 25cc two-stroke gas engine. As you can see, that silver thing, that's the centrifugal clutch. That would be connected to the gas or to the electric generator. Obviously it's a pull start, and I decided to do a two-stroke over a four-stroke, and I think I just talked about the difference between the two. The four-stroke is more reliable. It's a little bit quieter, and the reason why is, number one, is for price. This is only $45. And the second thing is that for the gas tank, the gas tank is so small that, and the same thing for a four-stroke, that there's no way you're going to use the gas nozzle at the gas station to fill that up. It's just going to be too dangerous. I don't think you can control the gas flow well enough that you're not going to eventually skirt yourself with like a whole bunch of gasoline and make, just have a pretty bad day by doing that, or just, get yourself in a dangerous situation. So along with this bike, I'll probably bring a gas container of some sort with pre-mixed two-stroke gas. So also for those who don't know, for a two-stroke you need to mix the oil, special two-stroke oil, into the gas. So that's what lubricates the actual engine versus a four-stroke, which has a separate oil bay or oil compartment to lubricate the engine. So, and just looking at the videos of the tutorial, it seems pretty reliable, the two strokes. And I've researched this engine pretty thoroughly, I think I know what the fail points are, and I think I can fix it if something does go wrong. And here's the picture of the step up controller. It's a 1500 watt system where it can take a maximum of 1500 watts. So I think it's 30 amps at the 20 volt, 16 to 20 volt range, which would be 20 times 30, which is 600 watts. So it's way over the actual motor, or way over the actual generator. And also, sorry, the motor, the two-stroke motor, supposedly can go up to 800 watts. So this can do around, so at 20 volts, 30 amps, around 600 watts. But obviously, I'm not going to take it that high. I'll probably settle somewhere around the 200 to 300 range, especially starting off. Maybe later, if I'm really comfortable with it and I'm going, I'm juicing and going pretty fast on the bike, I might push it to the 400 to 500 range, which is the upper limit of the actual generator. Again, I don't want to tax the parts, and part of the philosophy of this build is to try to make a gas serial hybrid that has the advantages of an electric motor, which is reliability and near instant torque, coupled with the range of a gas engine. Obviously, with a gas motorized bike, you can go pretty far in those swings. They have about 70 to 100 miles per gallon. Usually the gas tanks are about a third to, you can even get 1 gallon tanks for those things. So you can go pretty far, and there's obviously a lot of gas stations everywhere. So that's kind of the philosophy behind it, is to combine the advantages of the electric motor and the advantages of a gas engine. But the disadvantage of a gas engine is that if you tax the gas engine too much, it could possibly break. So that's why we want to not go too crazy on the generator. So the generator here is 500 watts. So I'm going to keep it around 200 watts, or maybe 150 starting out, 200 starting out. So which means that the gas engine would not be running too high. Because if you're to run the gas engine really high, there's no difference between that and just having a gas bike at that point, in my mind, because you're going to rear out that engine pretty quickly with extensive use. So that's kind of the philosophy. And here, with the motor, I actually have a controller in case I decided to take this motor off and make another bike or something like that, or a small foldable bike or something. You can put a 20 volt DC motor on that. It has the throttle and has the controller, which I would not be using for the actual setup, but just in case in the future I decided to take that motor off, this electric motor off, I can actually put it on a small folding bike and have a pretty neat ride. And so that's about it for the updates. The parts are on its way. Hopefully I'll get it within the next week or so. I'm hoping to get this all built and tested by, originally I was thinking the middle of March and ride it then, but then I think it would be still too cold, unfortunately, at that time to really do any really long distance riding or really serious testing. So I'm gonna push that back probably to the end of March to just get everything wrapped up and ready to go. And finally, here's a picture of a really cool bike that I found on Amazon, and also AliExpress has it. Unfortunately, this bike is not available anywhere from US sellers on eBay or any other places that I've seen. So it's a fat tire folding bike with dual suspension and dual disc brakes. And the reason why I bring this up is that so the bike this is on a Nighthawk Huffy Walmart bike. It has front disc brakes, which are great. They work really well. But the rear rim caliper brakes are horrible. They don't work at all. It's to the point where I don't actually have a rear brake, which is dangerous. Which is not great, especially if you're going very fast. But the speeds I go, it's okay. I don't go too fast at the moment. But in case I ever do want to go fast, that's a problem. So I'm looking to get a new bike eventually for my quote unquote final bike, where I'll possibly just take the motor off of the current Nighthawk and put it into this, or get a hub motor or high power hub motor for it. The reason why I like this, I also really like the fat tire look for a motorized bike. In fact, the fat tire does it does actually reduce the efficiency, obviously the rolling efficiency, since the tires are bigger. There's bigger surface area. They're heavier, but it's not that much. I mean, especially under power. I think it's between 2 to 4 miles per hour top speed. So it's not that big of a deal, especially you have the air pressure pretty decent, pretty high, as high as possible. I don't think it's that big of a deal. The other thing is that it's folding, and I really like the folding concept because I do use my bike to get to different places quite a bit. And let's just say, in case it's snowing really badly or it's raining really badly, it's thundering really badly, you can just fold it up really quickly, or design, the bike system to fold up really quickly, put it in the back of a car or a truck or something, or SUV, and just get dropped off. And then, later when you're done with what you're doing, and the weather is better, you can just, hop back on it and then just take off and just do what you need to do. So I really do like this system, but unfortunately this bike is $550, and it's gonna be need to be imported from China or from Russia, which would take quite a bit. But this is, I just want to share this because it's my country bike. Anyway, that's the